So maybe, Rajesh, I'd like to start off with a question for you.
Right.
What are the major lessons from scaling traditional infra that you think can be applied to machine learning, and what needs to be rethought?
Cool. Thanks for the question and thanks for the opportunity. So I think one of the lessons over the years that has made infra at Meta great is our ability to really think about reliability and making sure that our systems are as resilient as possible, right? So this means resilient to all sorts of faults. When faults happen, how do we quickly find and fix the problems? And what are the incident management? How do we simplify our operations and deployments and everything like that? How do we do more effective debugging? How do we make clear component boundaries so that different parts of the systems have different clear contracts and APIs of how they work and what they're supposed to do? And also like our efficiency programs to make sure that we're utilizing the hardware that we have to the best of our abilities. So I think a lot of that muscle can be directly applied, and we're seeing a lot of those muscles being directly applied right now, which is awesome. I think there's a few different things though that as we look forward, that is a little novel that we have to rethink about. For example, the when we look at our large distributed systems like that schedules our GPU fleet and stuff like that, we have to think about how do we do batch scheduling, how do we do tenant management. So for systems that are largely an online based systems, this was a new muscle that we've been like building out to a much larger degree than we have in the past. Um, I think another muscle that we have to think about is how do we debug model problems like numerical problems, and what are the tools and tool chests that we need to develop around that. Again, another thing around operability is as we do maintenance, right? The problem with large AI jobs is a failure of one node causes the entire job to stall out. So how do we think about maintenance in that regard? How do we coordinate and orchestrate the maintenance events? And finally, I think the as we look at AI, there's always obviously a brand new set of hardware that's coming online, and that's bringing a variety of challenges about debugging issues that are at the lowest levels of the stack, all the way through this how the stack gets integrated. So I think there's like a lot of those types of changes. So I think it's a mix of, you know, using the muscles that we have, but also trying to build out new muscles that we're still working through right now.
All right, Rajesh, thank you for that. Lynn, if I understand correctly, every week there's a new model being published, and there's a real issue with model fatigue that's happening. How does Fireworks scale to address that?
Right. That's indeed the biggest challenge our user has been telling us. And they want to focus on building innovative applications and new product experiences on top of this Gen AI technology. But the underlying building block keeps shifting for them, and it's kind of really hard for them to make decisions. Are they going to do anything, or kind of keep constantly catching up with this moving tide, or they're just going to forget about it and just pick one and stay with it? I think we are addressing that by being the one-stop shop and provide the best of breed of the general AI models across text, audio, embeddings for semantic search, image generation, vision language models, video generation models across the board. And we'll always feature the best of breed, the newest, for our customers to test it out, and then easy to scale production. So all the good things Rajesh has mentioned that Meta is driving, we are doing that for the industry. So hopefully we can alleviate a lot of those concerns to keep catching up with this constantly shifting tidal wave, and your most innovative applications can leverage what is happening, what is contributing by the whole entire community.
All right. Well, thank you. So yeah, so there are a lot of shifts and a lot of changes. So Kathryn, I mean, could AI-enabled tools have made Meta AI faster in the same way without needing experts in each particular area, like Copilot, automated unit test creation, or are we not there yet?
So we did use a lot of AI-enabled tools already through, like, if you count code completion, we also have like an internal tool called MetaMate that we used. But to go even faster and like without the experts, I think we're not there yet. We did need the experts in order for us to move fast, but in the future, I definitely think that we'll expand on our current internal AI-empowered tools to move even faster. We do have a lot of like customization internal tools in general that allowed us to build fast, but I definitely foresee us using AI power tools even more than we did already to move fast.
Thank you. So, Chris, you and Kathryn worked on the same project. How much of the Meta AI code was written using AI?
Yeah, that's a fun question. I actually suspect a lot of it was written by AI if you count code completion.
Okay.
So we internally have code completion. It's powered by Code Llama, which is open source. This gives us completion, which is very similar if you've used Copilot before. And I find it to be especially useful on very large code bases. And so I'm a big fan myself. I use this a lot. And in addition, Kathryn mentioned MetaMate being like the internal version optimized for like internal use cases. That's a very popular internal tool. As far as I understand, it's one of the most popular tools. And yeah, just I mean, code completion is only getting better over time. I actually expect this will increase every single year. So I'm really excited about that.
All right, excellent. Changing gears a bit, Stef, how do you decide when an AI feature is really ready to be shipped?
That's a great question, and I think compared to standard process of like validating a feature and seeing how much value it creates to the user, there's another factor that with Gen AI features you have to account for, which is the fact that once you are in market and then you can gather like real feedback and also data about how people can use it, your speed of iteration is going to go so much faster. So I think Gen AI in general is pushing the industry to ship sooner, less polished products. Maybe you can say it's more in the more than the minimum viable product is like minimum regret product. Because even though it's gonna feel like painful at the beginning, like because you're collecting real data you can use to fine tune or train immediately, then you're gonna get so much better and so much faster. And so I think probably the balance has shifted more towards like shipping early. In our case, we want, of course, to get strong signals that at least for a subset of the population, the Gen AI feature is creating a lot of value. It doesn't have to work 95% of the cases because you can just, create again and try again. And if you're basically spending 10 seconds on something that doesn't work, it's okay, as long as when it works, it saves you like an hour, right? And so that's kind of the philosophy. And that's how we are facing. And then we are basically thinking about it. And then again, the ability to collect real data in intent and solution, I think is pushing us even further on that front. And I think that's the best way to stay ahead of the game.
Wow. Really good insights. I appreciate that. So Rajesh, thinking about making the business succeed, how are you balancing the needs of new paradigms such as generative AI to make sure that businesses do succeed with existing workloads?
Yeah, that's a great question. I think as an infra org, our role is to make sure that all the products at Meta are successful, right? So we make sure that we're balancing our investments across the board to make sure everyone is good. I think there's a couple of different dimensions that we look at this problem through, right? The first is to understand when we get a set of requirements, like what is unique about that are unique to a particular product group, and what is common across the board. For example, as I mentioned earlier, debugging stuff for models and fleet management and understanding how different tenants will work on our batch scheduling workload. That's the kind of stuff that is common to a lot of people. And so we think, hey, that's actually a good investment for infrastructure to make in order to help everybody out. I think the larger scales of Gen AI are pushing the boundaries where we're forcing to innovate faster and faster, but we are highly confident that the innovations that we're pushing there are going to be helping everybody out. But that being said, there are definitely cases in which different product groups have one-off requirements. And it takes a very special set of talent and expertise that some of us in infra have, and that we'll just make sure that we work, right? And so I think hopefully these one-off bases are minimized and we take it on a case-by-case basis. But when they do occur, we figure out how to prioritize it and make sure that we're working on the highest level of projects possible.
Okay. Yeah, I agree. I definitely agree. So, Lynn, thinking a bit more about the business opportunities, do you think small models or big models will win?
Yeah, there's a huge debate about it today in the community. I think we're seeing we have onboarded a lot of very different type of companies, all the way from startups building never existing new application, and there are very exciting startups building on top of us. And also we are working with digital native companies like e-commerce or marketplaces, as well as traditional enterprise, all the way from healthcare, insurance companies, banks, and so on. So it's all happening at the same time. And when they come into applying Gen AI into solve a real problem and then scale after prototyping phase into production, they all start to concern two things. One is latency, and second is cost efficiency. The reason is fundamentally they are building consumer-facing or developer-facing applications or products. Whenever a human is on the receiving end, and it has to be interactive. If you lose that, you don't have the product viability. So and now we're also moving towards agentic world. That means it's not just one round trip where you extract information you need and put that in your application. It requires multiple models to work together to drive the results, and then latency becomes even more important. The second challenge is cost efficiency because Gen AI is on the highest end of the model size and complexity. It has to run GPU. GPU is very expensive. GPU is power hungry. Power is very expensive. Power generates heat. Heat requires cooling. Cooling is very expensive. So entire infrastructure is very expensive. So that significantly changed the business operation cost structure from building on top of commoditized CPU to build on top of very expensive GPU infrastructure. So then for the business owners who are innovating, whether they are big incumbents or small startups, if they lose money at a small scale, and fortunately they hit the product market fit, they can scale quickly, but that also means they're going to bankrupt quickly, even though they have the product. So it's kind of create these weird dynamics of their intersection of business viability is different, from all these parameters from before. So that's where all these companies onboarding to us, they started with the biggest model, they didn't want to worry about anything else, just make sure they have product market fit, it's a great product. And then once they scale, they start to worry about latency and cost efficiency. And that pushed them to actually use small models. And especially recently with Meta's Llama 3.1 released, we have the largest open source model for 5AB. And that model is really good, tremendous. This is a huge milestone for the whole entire industry because now small models are even more viable. We have a really big model we can kind of distill from, and Zach actually encouraged industry to use that model to distill knowledge and to power small models. I think it's just kind of I think small model has a lot of practicality, add a lot of practicality to both product viability and business viability in the whole in the industry. And small models are much easier to tune. The analogy I share with people is fine tuning is a process of aligning the models, and it's much easier to steer a tugboat than steering a cruise ship. So that's an analogy of like if you want to try to fine tune a large model versus small model is much easier to fine tune. So yeah, so I think overall, I see a lot of practical use of small models versus people do a lot of prototyping on large models. So that's kind of on the ground in the field. That's where. So Fireworks nevertheless we offer all different model sizes from the open source world and also proprietary models. We work with proprietary model providers. Our goal here is we want to alleviate your concern of, hey, model keeps moving. We just talk about it. And also hardware landscape keeps moving. We have emerging new hardwares from NVIDIA, from AMD, from custom ASIC companies. Our goal is provide the best of breed from all different angles. So you can come to fireworks.ai and all the way from exploring new ideas to scale your ideas into production.
Yeah, you're right. Yeah, really, it's all about the agility for product market fit, and actually then agility to make sure that you meet your business goals. Thank you. Yeah, and like thinking about agility, Kathryn, we know that AI is actually at the top of a lot of business leaders' minds, and there's pressure to ship on tight deadline and the visibility of the projects. How did your team handle the risks and issues given your tight deadlines and the visibility of launching Meta AI for the web?
Yeah, this is a really good question. The first is just like anytime there was a blocker or an issue, like just raise it immediately, like flag it as soon as possible. Don't wait. And that just gave us some signal into evaluating what potential risk it was. Another was evaluating the risk. Like, is this a launch blocker, or is this something that we can resolve beforehand? And if it was going to be a launch blocker, what are the alternatives that we can do to help like de-scope the issue? Like, is there a way where we can scope down the feature, or even just like what would it look like if we turned off the feature entirely? Another thing that we did was we ran a pre-mortem. So we got the whole group together and we asked Meta.ai was an epic failure when we launched. What happened? And as a result, it allowed us to think of different ways that, and a good exercise into like what things to start look into to prevent it from actually happening. Another thing that we did was constantly testing our product. So as we were building, we were testing it constantly on desktop and mobile web, and making sure that we triage those issues effectively to like the right workstream owners, and also seeing whether or not there are launch blocking issues. We also set a hard deadline for employee testing feedback. So we had enough time to try to get as much signal as possible. And on top of that, we also had like a triaging issue or triaging system where we had QA, user research, and product. They all helped facilitate all the incoming feedback we were getting, because there was no way we were going to spend all that time to just go through and parse all the different tasks that we're getting from employee feedback. So they were able to help us prioritize and understand like what's actually critical for launch blocking issues. And finally, finally, we also tried to simulate production as much as possible by running a smoke test. So we're like, well, how can we test this as close to prod as possible? And that gave us a lot of good signal there. And then also we have a lot of like knobs and switches for different features. So we just spent like a meeting where we just would turn them on and off, like different ones, to make sure that if we turned off a certain feature, another one was still working, and vice versa. So there are a lot of different ways that we tried to eliminate any potential risk for launch.
Wow, really great lessons learned. I think a lot of teams can actually benefit from the experience of this launch. So kind of clicking a little bit deeper into like the testing that you guys did, Chris, given the complexity of AI-powered features, what was Meta AI's approach to testing and debugging? What kind of frameworks did you use to scale the development?
Sure. So there's a lot of different philosophies around testing. A lot of acronyms around that. I'll just give you ours real quick. So if you think about it, like automated tests are almost like investments. They pay out the longer you get to run them, but it's not necessarily the best cost to reward trade-off when you're in a really big rush to launch. So for really quick development, you can kind of think of like inverting the test pyramid if you imagine that classical test pyramid. Basically, we end up prioritizing the really manual end-to-end testing, and then we'll introduce automated Jest end-to-end testing, and then unit tests after that. And Jest is the name of the framework, also open source, I believe. Okay, so the rationale behind that is basically that if we're only going for 4 weeks, we're not really harvesting a lot of time savings from test automation. And we're also pre-production, so even if we do introduce bugs, the cost is lower, right? So that's just the cost reward trade-off there. So in terms of our actual development, as Kathryn was mentioning, it's a lot of like heavy dogfooding, a lot of employees using the product every day, bug bashing, where employees will get together for 30 minutes to an hour and just have a go at the product, trying to break it in all ways possible, and a lot of manual testing on diffs before landing them. We basically skipped almost all unit tests except for the really core stuff, and we added automated end-to-end tests in the weeks before launch.
All right, excellent. I'm glad, this is a good way to really move things quickly. So now, kind of looking at it in a different dimension of development. So, Stef, how does Roblox scale to build its training data for AI? I'm sure there's a lot of challenges there.
Yeah, there's a lot of challenges because ultimately what we are trying to teach AI is game development, right? We have all kind of experiences on the platform, and we built Assistant. That was the first integrated AI assistant for game development and experience creation. But experiences are made of 2D assets like images, 3D assets like 3D models with texture, and also code all together, and then audio, and then UI, interactivity, and so on. So it's highly multimodal, if you want, a multimedia. And so the challenge is that we have, in order to learn that, we have to basically have training data that contain all of that, right? And ultimately, those are made of experiences itself. And so we need a large volume of games and experiences to train our AI. And then we need to also extract the intent from that. And so we basically went straight to our community, and we explain what we're trying to do, and we ask them for permission to use their data and their experiences. And so a lot of those people, I would say the vast majority, agreed to give us their data, because ultimately we are trying to improve Roblox Studio, which is our development tool, which is free, right? So we are not even monetizing, unlike other companies, we're not monetizing on the tool itself. And so I think the community understood that we were just trying to help them, and gave basically a large access to their data. And so that's what we are using. So we're using our own data on the platform. I think it's public information that in a year we will get like about 15 million experiences. And so the amount of data is enormous. We have like hundreds of thousands of experiences published every day. And that's basically the backbone for our training sets. And it's been like non-controversial, again, because we develop like a very high transparency with the community from the get-go, and we included them in the conversation. And so we got actually a lot of support and very little controversy on that topic.
Well, thank you. Thanks for sharing that. No, those details. I really appreciate it as somebody who uses Roblox. Thanks. Well, that was a fabulous discussion. I mean, I learned a lot more about, asking these questions. I hope that our viewers have actually gained some more insights to, how you can really scale your products using AI. And again, I want to thank Rajesh, Lynn, Kathryn, Chris, and Stef for joining me for this live Q&A. Thank you.